Hey everyone, Mr. Nicholson here. This week I'll be doing an example for our introduction lesson to calculus. And although it is a great lesson, I do feel like maybe it has its limits. Sorry. Good stuff. Calculus is something that hopefully you will all be taking next year. Fun fact, I did triangulate my resources on this, but calculus was actually invented in a similar time. Isaac Newton did invent calculus during the plague. So if you think you're bored, try inventing a whole new math system like calculus at a time like this, right? My example, I know Mrs. Gerber did a couple and Ms. Van Uwegen did another direct substitution. The example 3, though, we get to choose how we go about solving this. It just says, given the function 2 cosine of x, evaluate the limit at pi over 6, or as the graph approaches pi over 6. I guess the first thing we can do is look at, graphically. So let's go back to the example 1 method. So if we were to go into our equations in our graph, we would see 2 cosine theta. First, we would, before we even did that, you might even double check because we are being given a radian point. So pi over 6 is in terms of radians. So we do want to make sure we're in radian mode, not degree mode. And we make sure we put our function in correctly. And then I'm going to go ahead and just graph this from negative 10 to 10, which is that zoom 6. In fact, let me move this over here. Zoom, and then 6 is that standard window. So if we look at this, we can trace that. I know that was a method Mrs. Gerber used. And I'm going to actually, what I'm going to do is I'm going to go directly to pi over 6 here. And the value itself is 1.73. So, I'm going to look at this from a graphical standpoint. I see it's continuous. And when it's continuous, what that means is I don't have to lift my pencil the whole time I'm graphing. And as I trace this value, I'm going along, and pi over 6 itself is around a half. So again, let's go right back to pi over 6. And it's 0.523. So as I go along my graph, I can see that as I'm approaching the 0.5 mark, I'm getting close to 1.9, 1.8, 1.65, and I've already surpassed my point. So, we could just use that method, tracing pi over 6. And we would say that, this value is 1.73205008. And so we can say the limit is, I use that symbol, it's approximately 1.7, how far do we want to go? 1.732. And that is the approximate value. It does say we need to find the exact value. So how are we going to do that? Well, that could be a matter of using, I don't even know if you could use the calculator for that part. What we could do, though, is use more of Mrs. Van Uwegen's method, which is the direct substitution. So if we were to plug in 2 times cosine of x, where x is pi over 6. Let's see. Graphically, we know that that will be the value because we know that no matter whether we approach that point, pi over 6 from the left, or if we approach it from the right, we will get to the same value. So if we look at that, we need to go way back, was it first semester? And what we find is we have a unit circle problem, and we're being asked for cosine pi over 6. So let's see, get those unit circle sheets out. Just kidding, you should have those memorized by now. Cosine starts at 1 and works its way down to 0 at pi over 2, as the graph shows. So as we go from 1 to 0 on our sinusoidal function, we should remember that this is really the value of square root 3 divided by 2 times 2. Sorry, let me, you know what, I'm not going to restart the whole video. Let's just correct that. I want to make sure this looks exactly how it should. So I'm going to say that is equal to 2. I'm going to put the 2 out front is all I'm doing. 2 times cosine pi over 6, right? This is what becomes square root 3 over 2. Okay. So using the simplification process, we find that the limit is exactly equal to, well, let's see, 2 times square root 3 over 2. Those 2's reduce to 1, and we're just left with square root of 3. And we can check that, you know, if you go in your calculator and you just say, you know what, I'm going to X it out and I want to know what the square root of 3 is equal to. That is exactly what our graph gave us. So again, a couple ways to go about it. Finding the approximate value, I would just use graph tracing. You could use table like Mrs. Gerber did, or if we need an exact value, we can plug it in as long as we confirm that from the left and the right, the values are going to be the same. We know it's continuous, and therefore we plug it directly in and we use our unit circle knowledge. And that is my example. If you have any questions, please let myself or your own honors pre-calc teachers know. We are glad to help. But otherwise, thanks for listening.